partial fractions. So before we do the partial fractions, we want to make sure we have a proper algebraic fractions. We check the highest power of x in the numerator and denominator. This is 2 and this is 3, so we say the order is 2 and 3, the highest power of x, which means this is a proper algebraic fractions, no need to do long division. The next step is to identify the types of partial fractions we have to use. Because of the simple linear, we use a constant divided by x minus 2, and because of this unfactorizable quadratics, we use something linear divided by 2x squared plus 3. The next step is to multiply both sides by this denominator, because on the left we will cancel out, and on the right, after we multiply, each term we multiply, we cancel out, we have a times 2x squared plus 3. And when we multiply the next term, we cancel out, we get bx plus c times x minus 2. Notice that the brackets are important here. Now, since we are combining the bx and the c in the same term, we're going to have to split it to find the b and the c faster. So we do bx times x minus 2 and c times x minus 2. Now we have all three coefficients a, b, c in three separated terms. The next step is to cleverly choose the right values of x so that we can find the ABC as quick as possible. That is by using the zeros. Zeros means the values of x that make the factor 0. So here we plug in 2. On the left we replace the x with 2, replace the x with 2. Here we replace the x with 2, we have 2 squared times 2 plus 3, which is 11. And here if we plug in 2 minus 2 is 0, so this term goes to 0, this term goes to 0. So that's why we choose 2, because we will make terms go to 0, which means we can find the a directly. So this is actually 33 divided by 11, we get the value of a. And then we can use also x equals 0. So if we plug in x equals 0, we have minus 3 on the left. On the right, when we plug in 0, this is 0, so we have only 3 times a, but we already know the a is 3. And when we plug in 0, everything cancel out here because 0 times whatever is 0. And if we plug in 0, we get minus 2 times c. So this is minus 9, move to the left, minus 9 I mean, so 9. Move to the left, minus 9, so we have minus 12 divided by minus 2, which is 6. And for the last coefficient, because we already know the two other coefficients, we just plug in something random other than 0 and 2, but use something simple like 1. So plug in 1, we get 5, plug in 1, we get 8, and we can simplify everything on the left. Now we plug in 1 here, we get 2 plus 3, which is 5. We already know the a. And we plug in 1, we get 1 times minus 1 times b. We plug in 1, we get minus 1 times c. We already know the c. So we can find the b now. Use a calculator, we get 10. This is 15, and this is minus 6. 15 minus 6 is 9. Subtract 9 from both sides and divide by minus 1, so b is minus 1. So we have a plus bx plus c for the final answer. Alright, I'll see you again next time.